I remember how to do this today.
I'll just read through.
I think I might have messed up a few of them, because for a second I mixed up my cosecant and secants, but I'm not quite sure how many I messed up on.
I'll read through the answers and then we can go over questions that you have. Alright, number 1 is the square root of 3. Number 2 is the square root of 2 over 2. Number 3 is 1/2. Number 4 is 0. Number 5 is 1. Number 6 is the square root of 3 over 2. Number 7 is 0. Number 8 is negative 2 square root of 3 all over 3. Number 9 is negative square root 2. Number 10 is no solution. Number 11 is negative square root 3. Number 12 is negative 2. Number 13 is 1/2. 14 is negative square root 2. 15 is 1/2.
I got negative 1/2.
We'll look at it. I could be wrong too. I worked these out. So. 16 is no solution. 17 is square root 2 over 2. 18 is no solution. 19 is negative root 3 over 2. 20 is negative 2 root 3 over 3. 21 is 1. 22 is square root 3 over 3. 23 is negative 1/2. 24 is negative 1. 25 is negative 2 root 3 over 3. 26 is negative root 2 over 2. 27 is 2 root 3 over 3. 28 is negative 1/2. 29 is 0. And 30 is negative 2 root 3 over 3. So,
Some of them I had like no issues with, and the other ones I got like completely off.
well, it's very easy to make small mistakes that totally change your answer, right? Can you guys see the unit circle up here? Okay. So, I'll just leave it up. What questions do you have?
I remember my first one's number 13.
Do you have any before that, Olivia?
I got 9 and 11.
Alright, 9. And how do you look at them? How do you do this?
Oh, this is gonna get confusing. I think we look at them
I
different
know.
ways.
I think all 3 of you did it a different thing, but I want to help you how it makes sense to you.
I just went to 3 over 4. No. I have negative 2 over square root 2 times root 2 over 2 written down, but that doesn't really make any sense.
Okay. First of all, you need to figure out what negative 3 pi over 4 is corresponding to.
I think
Right.
I used the 5 pi over 4.
Okay, that's right. Okay. You like to think about it like here's 3 pi over 4 and it's negative, so it's 5 pi over 4.
Mhm.
Okay. So that's right. And then it's secant, which is 1 over what?
Cosine?
Well, I would think, well, that's fine. Yeah, secant is 1 over the cosine. And cosine is the first one. It really doesn't matter in that one because they're the same. But 1 over negative square root 2 over 2, which would be like 1 times 2 over negative root 2. Right? So that would be like times root 2 over 2, or root 2. So that would be 2 root 2 over 2, and then and it's negative, and then the 2 would cancel, so it would be
Oh.
negative.
That's what I did, I just didn't, okay.
Got
Cancel
it.
the two, yeah.
Okay. That's fine. And 11,
Mm-hmm. But I can, okay. It's just supposed to be root 3.
negative root 3. Yes.
Okay, that makes sense.
Okay. Skylar, you said 13.
13.
So what were you looking at to find the sign of?
I do, where I find one that's bigger and then you subtract.
Okay, so what were you subtracting?
I add 24 over 6, so then
Okay.
I got pi over 6.
Good, that's right. So the sign of pi over 6 is 1/2.
Oh, I just looked at the wrong one. I'm stupid.
No, you're not stupid.
I looked at the cosine and then it's the cosine.
That's an
Okay.
easy fix. Okay.
I was like, okay.
That's alright.
My next one's 15,
15,
but pretty sure.
Is 14 just supposed to be root 2?
negative root 2, yes.
Okay, I got that one fixed.
Okay, so you just have simplifying issues.
Yeah, and
That's an
my,
easy fix too.
I might have done, because I got negative 1/2 instead of just 1/2 for 15.
Well, what did you change 13 pi over 3 to?
I got 4 pi over 3.
That's the problem.
Oh.
So,
Because I subtracted 9 over 3, is that wrong?
but 9 over 3 is 3, which is not an even. It has to be 2, 4,
Oh.
6, right?
Okay, so it has
So
to
you'd
be
want to subtract
12.
12 over 3.
So it'd just be pi over 3?
Yes.
Okay.
Okay. What else?
For number 21, I got -1, but it should be 1 on it.
How did you think about that one?
I made it 5 1/4 pi.
Okay.
So I was over at the pi, and then do I go all the way around to pi over 4, or do I stop at 3 pi over 4? Because I stopped at 3 pi over 4.
Okay, so you are, so it's
Oh, but
5,
it's not negative.
so it's 5, so 2, 4, 5 pi, and then 1/4 from here would be
Okay.
5 pi over 4.
I went the wrong way. Okay.
Does that make sense?
Mm-hmm.
Okay.
What's your next one?
Okay.
What's my
27?
Yeah, I got -2, so I think I might have gone the wrong way again.
Yeah,
I
what
did.
did you change 14 pi over 3 to?
4 2/3.
Yeah, it should be 2 pi over 3. Cosecant of 2 pi over 3, which would be 1 over the sine. So 1 over, where's 2 pi over 3? The sine. So 1 over the square root 3 over 2. So which would be like 2 over square root 3. And then you have to
Okay.
multiply by.
I'm not sure what I did there.
Did you use the sine or the cosine instead of the sine?
I don't know where I got -2 from.
Yeah, you did. Then you use the
I did.
cosine.
Okay, but I should have used sine.
Yes. Did you say 28 there?
Yeah. What was the answer for that one?
Negative 1/2.
Okay, I got negative root 2 over 2.
You should be looking at 4 pi over 3.
I was.
So you just put the wrong one then. It's cosine, that's the first one. You just put the sign. You just put the sign.
Retarded.
It's okay. There's a lot to think about on these.
It's like, I know what I want to say. I even have at the top of my root, at my unit circle, I was like, it's cosine, cosine. But I Apparently I still can't follow it.
So cosecant is like the reciprocal of sine?
Yes.
Okay.
Okay. Anything else?
I had number 30.
30, what did you change that to?
I got pi over 6.
That's the problem.
Right there is the problem. You can't do that.
You did 6 over 6, didn't you? Did you do 6 minus 5?
Probably.
And 6 over 6 would be 1 pi, and it has to be an even number of pi. So you have to do
So
12 pi over 6. So 12 minus 5, so you're looking at the 7 pi over 6 for that one. So secant is the opposite of cosine, so it'd be 2 over negative root 3, and then you have to rationalize that. Okay? Now that you know how to do this with the unit circle, let me show you how to use your calculator.
oh boy, let me get more things.
I think it will be less, well, who knows what your calculator does. The only thing with the calculator is it doesn't have the inverse functions. It doesn't have secant, cotangent, cosecant. Let's look at yours for a minute before.
The most confusing
Come here,
calculator.
Lauren, to look at a calculator.
Calculate.
Ready,
Okay.
ready.
Oh, guess what? Yours
Yours
does
does.
have it.
Fancy,
I was
Skylar.
figuring it's mine probably hasn't.
It doesn't surprise me.
Just because it's fancy.
So you just need to be on calculate and then go to trig and you can pick. You want to use the top ones.
Oh, look at that.
And I don't know.
It has the
Check
inverse
your
of the
mode.
infinity.
Check your mode and make sure it's in radians. I don't know how to get to your mode. Settings. No. General. Yes, okay. Maybe. Angle. Angle radians. Did you see how I did that? Yes. So you can change it to degrees if you need to. Yes. We should be always in radians, though I can't think of why we would need to be in degrees. So, did you switch your mode to radians? Okay. So then, anytime you want to find it, you just go like, I don't know, sine of pi over 2. You just type in sine, and then do you know where the pi is?
I've seen it before.
Pi is above.
Oh,
There's a
that one?
second.
Okay.
And then pi divided by 2.
Where's my pie?
Then here.
Where's my pie? Hey, look at that.
What in the world?
Like like imaginary number. And remember when we talked about E? I
I
remember.
remember you.
I don't remember what it is, but I remember
The
talking about it.
natural number. And then hit enter, and then it will give you
What?
the number.
Sine of
The
pi.
problem is also that it doesn't do, it doesn't have like exact form. Like it's not going to be in radical form. So we won't have the exact value. Like if we have square root 2 over 2, it's just going to give you a decimal. These do not change things into radical form. Yours might do something like that. I don't know. So you might be lucky. But if you are looking at your unit circle...
Could I change it to a fraction?
You can change it. It won't
Oh.
change it to a radical. I looked it up on the internet. There's no way to do it.
Bummer.
Yours might do it. Who knows? But if you're using your unit circle or you want to check your answers, you can check your answers that way and just type in like square root 2 over 2 and and then see if the decimal is equivalent to your answer on your calculator. On these calculators, if you want to do the inverse functions, you have to do 1 divided by and then do whatever
Okay.
it is. So 1 divided by sine or 1
So
cosine or whatever.
it gives you a decimal and that's your answer?
Well, see, that's not right. Because the sine of pi over 2 should be 1. So
What's yours?
that's a problem.
Maybe, wait,
But we changed it to radians.
maybe you have to press save when you, so what did you do? You
Five.
went to
5 for
settings, yeah, settings. General, oh no, it's saying
It says radians.
what's
Gradient.
Skylar calculator is crazy.
I don't know. But that's how you would check it. We'll have to figure out what's going on here. Because that's not right.
Radiance.
That's how you check it on your calculator. Alright. When I looked at your guys' notes, I didn't see anything on trig identities. Did you guys ever do trig identities?
Somehow, trig identity function, that sounds familiar in my head, but maybe I'm just
well, I
making
mean,
that up.
I know we did identity function because I have here an identity function in my words.
Yeah, I know we did
As a
identity
quote in my
functions,
notebook.
but
So
I don't think we did this.
Okay.
I don't think so either. Just
Okay.
now.
What these are things that are equal to other things in the trig world. And we can use them to simplify more complicated trig expressions. So I'm just gonna give you your assignment and then we're just gonna do examples off of it. Basically, you can replace anything that's equal to something else and it will simplify the trig expression. I personally love these. I love simplifying things that are more complicated into something that's more simple. I don't know if you guys do or not, but I think
that
it's
is a lot of
so
problems.
fun. We're just gonna do the odds, and we're gonna do some together right now. Okay? So you obviously will need another piece of paper.
No. This not so pretty. This is pretty up there.
Okay.
It looks like a disaster.
Actually, yeah, there are a lot of them. Let's do 27 to start with. So cotangent of theta, secant of theta. The easiest thing to do is to use the reciprocal and quotient identities. That's the ones that you're going to use most often. So, and to put things in terms, try to put everything in terms of sine and cosine, and then we can simplify it. So, if you look at the quotient identities, cotangent is equal to what?
Cosine over sine?
Right, so we're gonna put cosine of theta over sine of
It
theta.
doesn't show up on the
Oh,
We're looking at home so
oh. Now?
yes.
Okay, good. Alright, so we'll change cotangent into cosine over sine, and then secant, if we write that in terms of sine and cosine, what would it be?
Secant is tan or cosine?
What with the cosine? You can look at your reciprocal identities in your paper.
1 over
1 over cosine theta, right? Are we following this? Yes? Okay. So then do you see how we could go about simplifying this?
You can cross multiple. You can cross out the cosine.
You can cross out the cosines, right? So that will leave us with 1 over sine theta, and 1 over sine theta is what?
Cosecant.
Cosecant, that's right. So to simplify cotangent theta secant theta, we can do that, and the simpler form of that would just be cosecant theta.
I feel like we did these, but we did them
With
with
numbers?
degrees, and we had to use the 30, 60, 90 triangle.
I feel like we had to find the simplest form of like,
Yeah.
we had to
We
do
did
with numbers.
something like this, but we didn't,
Kind of, but I don't
there
really
with
know.
numbers instead of.
Maybe.
Okay. Does it make sense? Yes, okay. Let's do 33. 1 minus sine squared x over cosecant squared x minus 1. Now, looking at your identities sheet, which category of identities do you think is going to be helpful for this problem?
Or no, this one.
Pythagorean?
Yeah.
Yes. The Pythagorean identities are going to be helpful for this. So, I can rearrange that first Pythagorean identity, the one that says sine squared u plus cosine squared u equals 1. I can rearrange that if I subtract sine squared u from both sides. Then I know that the cosine squared u equals 1 minus sine squared u. Does that make sense? I'm just rearranging that identity that I'm given so that it will look like this. 1 minus sine squared u. So that is equal to cosine squared u.
Or would it be u or could it just x?
Oh, sorry, x.
I
It
was
says
like,
u on your paper, but in
I was
this
like, are we
case,
mixing variables
yes,
now?
no, sorry, it is x, my bad. Okay, and then we can also rearrange the last one, the one that says 1 plus cotangent squared u equals cosecant squared u, so that it looks like the denominator of this. If we subtract 1 from both sides, then we get that the cotangent squared u equals cosecant squared u minus 1. So this would be the same thing as what? Cotangent squared x. So then we have cosine squared x over cotangent squared x. Do you think that's in simplest form? Nope, it's not. So, cosine we can't really simplify that much more, but cotangent is what?
1 over tangent?
1 over tangent, which is usually not very helpful. The more helpful one is the quotient, is to put everything in terms of sine and cosine. So that would be what? Cosine, yeah. So cosine squared x over sine squared x. So then I would write that as cosine squared x over 1 times sine squared x over cosine squared x. Right?
And you can cross it out and then you just get sine.
Yes. So then it's sine squared x.
There's such a hard problem.
That's
with
gross.
this.
You don't like it? I love it.
There's so many
It's so fun.
steps for one little
I
thing.
know. I'm one of those people that like to skip steps and just get to the answer.
Well, like, I don't know about you, but you could probably look at your sheet and tell that those are true. But do you need to actually work it out to yeah, you could probably just look at your sheet and see this. You probably don't need to write all of this stuff down. I just wanted to show you where that was coming from.
I just like to find the shortest way possible of getting everything done. It's just how I
Okay,
find little like
let's
I'd rather
do,
like tricks factor
um,
out the negative one.
Ew, no, that's gross.
I'd rather do that.
You'd rather do what?
Like
rather, like, factor out
the
the-
negative one and multiply
making it
by
more
cosecant
confusing.
over 1 and cancel out
Stop.
cosecant.
Gross. No.
I don't think it's
Okay,
that
let's do
possible.
45. You are gonna have to factor for this one. They kind of give you hints. This one says factor the expression and use the fundamental identities to simplify. So, what can factor out of this?
X.
Remember, like, trig is like all one thing. There aren't any like plain x's here. It has to be together. It's like the tangent of x or the sine of x.
Well, how
Are
can
all
you factor
together.
anything out if they're not all the same?
Well, we could factor out the tangent squared x. Because there's a tangent squared x here, and there's a tangent squared x there.
But sine squared x is.
But that's multiplying by the tangent squared, so we can factor it out.
Okay.
So if we factor out a tangent squared
Factoring, stupid.
x from the first term, we're just left with 1, right? And if we factor out the tangent squared x for the second term, what do we have there?
Sine squared.
Minus sine squared x. Right? Okay, what?
I said we.
So what do you think is going to be helpful? Which kind of identity will be helpful at this point?
Tangent equals sine over cosine.
Eventually, yes. But let's first take care of the 1 minus sine squared x.
Oh, the Pythagorean.
Yes, the Pythagorean identities.
So it's tangent squared x percent cosine.
Right. Because of the Pythagorean identity that says sine squared u plus, you don't have to write this is just to help you. If you subtract sine squared from both sides, you get cosine u equals 1 minus sine squared u.
How do we know?
So that's cosine squared x.
Like, how come we don't mess with the tangent squared and plug in, like, secant squared b minus 1? How do we know?
Because
which
that
one?
would make it more complicated.
Because you have to complicate.
We want to make it less complicated. So like that would make one term go to 2 terms because
Mhm.
tangent squared would become secant squared and a 1. And like I said, ultimately it's best to get everything in terms of sine and cosine because then we can start canceling things. So how would we simplify? We can simplify the tangent squared x.
Cosine.
To be what?
Cosine. Cosine squared x over sine.
Opposite.
Why?
It's sine. Tangent is sine over cosine.
That's what I wrote down, I just said it backwards.
It's fine. That's the important part. You know what you're talking about.
I was like, I swear I wrote it down right. I was gonna say, I did.
So then what will happen there?
Cosine.
The cosines will cancel, and so that will give you sine squared x. Again,